All right, hi everybody. This is section 6.2. It has to do with the normal curve and normal distribution. Once again, normal curve and normal distribution looks like this. The center is the average or the mean. The center is a mean. And then to the right or to the left are z-scores. We call them z-scores. And z of 1, a z equals 1 is 1 standard deviation away to the right. A z, and this is a -1 to the left of the average, is a z of -1. And right on the average, we call that a z of 0. So z is another way of saying how many standard deviations away from the average are we. And to calculate the z value, we're going to use this formula. This is population average. I keep on saying average. In stats, we always say mean. And this is this population standard deviation. And then we just call this the value. There's the mean, standard deviation, and value. By the way, we could use this formula, and I think they write it down later on, the x minus the mean over the standard deviation. So this is the sample formula, right? The sample mean and sample standard deviation. So both of these are the same. And x is the value that we're talking about away from the mean. So here's the mean once again, and the x value is wherever we count it. Once again, you got to watch that 6.1 video to get a starting understanding of this. So here, liters of blood, an adult has an average of 5.2 liters in their system. Do you see? This is the average. This is the mean. Their mean is 5.2. That's the average. Has an average of 5.2. Assume the variable is normally distributed. This is a normal distribution curve and a standard deviation of 0.3. Find the percent of people who have less than 5.4 liters of blood. So we want to know, here's 5.4. This is the average. We want to know what portion is shaded in. If the whole thing is shaded in, it's 100%. So I want to know what percent is shaded in right now at 5.4 if the mean is 5.2. So once again, if we just look at this, just this half, that's 50%. So we know the answer is going to be more than 50% shaded in. We have to find the z value right here. We know this z value is 0. The average is always a z of 0, but we have to find this z value because this is where it goes shaded into the left. So the z value equals x minus the mean divided by the standard deviation. The x value is 5.4. That's the value that we're talking about. The mean was 5.2. See, there's the x value, there's the mean. And the standard deviation we said was 0.3. So when I put this into my calculator, 5.4 minus 5.2 divided by 0.3, I get a z value of 0.66666, and we always round z values to 2 decimal places. So we look to the right, 5 or more, you add 1. So our z value at this spot is 0.67. Our z value at that spot is 0.67. So I'm going to erase this. and show you our Z value is 0.67 at this spot. So we want to know what percent is shaded in for a Z value of 0.67. I'm now going to my calculator to show you how to type that in, if I can remember. And I'll write it down here in a second. I'm going to go to my calculator. There's my calculator. So we want to go to the Z value of, to the left of 0.67, second vars. So let me see if we need to hit focus first. I think we're okay. So second, and then the vars button. And for the Z value, we're going to go to normal CDF, number 2, normal CDF. And normal CDF only goes to the left. So if you look at this, the lower limit, I got to go back to the picture for a second. I want to show you. I need to go back to the picture, sorry. So we said this Z value is 0.67. If you look at the shaded part, that's the left side, the right side. That's the right side. Now, does anybody know what this Z value is way over here on the left? Can anybody type it in? Tell me what do you think that Z value is? What is the Z value way over there on the left? And some people are typing in. It's not -1, but that's a very good try, John. It's negative infinity. Do you see? This might be -1 here. This is, by the way, this is Z of 0. This might be -1. This might be -2. But when you go far, all the way to the left, it's a negative infinity. Okay. So in Z values for negative infinity, I'm just going to type in -99 because that's more than you need. A positive infinity would be positive 99. So for Z values, -99 is negative infinity, and then our right side is 0.67. So far left is -99, far right is 0.67. So once again, I mentioned this in 6.1 video, which you guys should have watched. I was concerned when I didn't see anybody do that homework. I was really concerned. So we're going back. Wait, I don't know. We're going back to stop sharing. So the lower limit is the far left, -99. So I'm not typing in -99. I'm typing in -99. The far right was 0.67. And the average is going to stay at 0 because that's what our Z value is. And our standard deviation is always 1, that we always put it in there. So keep our mean 0 and our standard deviation 1. We're just putting in the lower and the upper parts. The lower is the left-hand side of our graph. The upper is the right-hand side of our graph. Remember, a 0 Z value is 50% of the graph. We're more than 0. We're at 0.67. So our answer should be more than 50%. When I hit enter, 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 and enter one more time, do you see right there is my answer, 0.74857. We take all percentages. I think they take it to 4 decimal places. So this is the answer. You should have this on your calculator if you're following along. And I really recommend following along. So the average, when we did that, by the way, in order for us to do that, we went to z-values to find percentages to find percent shaded, and it's always shaded to the left, by the way. You can only shade to the left. Our calculator will only, actually, no, it won't. Don't even worry about shaded to the left. Our calculator will do whatever we want, a left and a right side. The left side was negative 99 that we typed in, which is negative infinity, same thing. The right side was a z-value of 0.67 that we calculated. And then the answer on my calculator is 0.74857. If we take it to 4 decimal places, 0.7486. Because you add, since the number to the right of the fourth place is 5 or more, you add 1 to the underlying number. So that's the answer. 74%, a little bit more than 74%, 0.7486 is shaded in. Once again, if the whole thing was shaded in, you'd have a 1. 1 is 100%. And once again, there's the 0.67, and we got our answer of 0.7486. All right. If there's any questions, just yell them out.
So, sir, why do we have to go 1 less again?
We didn't go 1 less. Oh, we went. Oh, you're talking about the spaces?
No, I'm talking about like the 0.74857.
Oh, yeah. You go 1 more. Do you see? We're going to round it to 4 decimal places. So you have to go 5 decimal places. You have to go 1 more. So we're only doing 4. But you have to look at the 5th to see if you're going to add 1. If this was 5, 6, 7, or 8, you add 1. If it was 4, 3, 2, then it would stay at 5. So okay. We're just looking to round it. Since it's 4 decimal places, you always take it 1 decimal place more, to round it up, or just leave it alone. You never take it down.
Okay.
Good. Good. Perfect. All right, so we're going to do the same thing with this. We're going to try to find out what percent is shaded in. In order to find what percent is shaded in, I need to find the left z value, and I need to find the right z value. I need to find these 2 z values, what's shaded in between these points. Now, 28 is the average, it looks like. That's the one in the middle, and it says right here, generates an average of 28. 28, that's where z is 0. So at the average, z is always 0. So we know this z is going to be negative because it's on the left of z0 of the average, and this z is going to be a positive z. We just have to calculate both of them. So to calculate the z value, it's x minus the average divided by the standard deviation. Once again, z equals x minus the average divided by the standard deviation. The x value, first we're going to find the z of this. That's the value we're looking for. That's x, 27. The average was 28. And the standard deviation was 2. Do you see? Standard deviation was 2. So when I put this in my calculator, 27 minus 28 divided by 2, I get a negative 0.5. My left side z value is negative 0.5. I now need to find my right side z value. That's the left side. The right side, the value we're talking about is 31. The average is 28. And the standard deviation is the same. It's 2. And 21 minus 28 is 3 divided by 2 is a positive 1.5. So this z value is a positive 1.5. So when we do our second vars number 2, this is the left side that we type in, negative 0.5, and this is the right side. You see, I want to find the shaded between the left side and the right side. So I'm going to go to my calculators now. You have to use that formula that we just used to get the z values, and then you plug those z values into your calculator. All right. So once again, if you haven't written this down, write it down. Second vars number 2 for normal distribution. Hit enter. The left side we said was negative 0.5. The right side was a positive 1.5. The lower is the left side. The upper is the right side. Leave your mean at 0 and standard deviation at 1. So we have everything we want. We want to know what portion of the curve is shaded in between these two spots. And the answer is 0.6246. Hopefully you guys got that if you're following along.
Can you do it one more time, please?
Yes. Let me go back. So we're going to go to second vars number 2. Normal CDF is our normal distribution, normal CDF. And when I hit enter, I'm going to put negative 0.5 in for the lower, that's the left side. And we got a 1.5, positive 1.5 for the right side z value. So you type in your left z value and your right z value. And when you hit enter, enter, you should get 0.62465. Did you get it?
Nope. I'll talk to you after class.
All right. So once again, we typed in negative 0.5 for the left side. We typed in 1.5 for the right side. We went to second vars. And then we went to number 2, normal CDF. And the lower is the left side. That's where we typed in negative 0.5. The upper is the right side. And we typed in 1.5. And you should have got 0.62465. And 4 decimal places is here. Since this is 5 or more, you had to add 1 to that, and you get 0.6247 as our answer. So about 62% of the graph is shaded in. Do you see the shaded in part is 0.6247. That's the shaded in portion. And by the way, on the test, there are about 6 or 7 questions with this in here from 6.1 and 6.2, and I think 6.3. There are about 6 or 7 questions on doing this on the calculator. So you got to know how. Those of you that are sleeping right now, you got to know how to do this. Okay, let's move on. I mean, once again, that 6.1 video, if you haven't watched it, you got to watch it. So here, if you look, we're trying to find out what portion of the graph is shaded in. We know it's a very small portion. You can look at it. So the answer should be a small percentage, very small portion. Let's read the question. Uses 120 watts of electricity per hour based on 4 hours of use. The variable is approximately normally distributed. Standard deviation is 6. So our standard deviation is 6. And a desktop uses 120 watts of electricity per hour based on a 4-hour use. That's an average, even though it doesn't say it, but that's an average. 120 is the mean. This 4 hours doesn't mean nothing. That means just uses 120 watts per 4 hours. So the standard deviation is 6. And this is going to help us to answer the actual question. 500 PCs are selected. How many will use 106 watts? So 106 is our X. That's the value we're looking for. You know, that's the Z value we're looking for, the X value. The formula is X minus the mean divided by the standard deviation. That's how you find your Z value. X is 106. The mean is 120. There's the mean right there. And standard deviation, we said, was 6. So when I put this in my calculator, obviously the Z is going to be negative. It's on the left side of the mean. 106 minus 120. I hit enter, and then I divide it by 6. And I get a Z value. Of negative 2.3. Decimal places only for Z values only go 2 decimal places. It's 0.33, but if you, one decimal place. I think we do get 1 decimal place. Or maybe 2 decimal places. They'll tell you. 3. Yeah, we'll go 2 decimal places on the Z values until they tell us something different. If you see 3 is, you don't add 1 to it, so it's negative 2.3. So this Z value here is negative 2.33. That is, can somebody tell me, is this the right side or the left side that we're looking at? The upper or the lower? That 106. This negative 2.33, is that the right side or the left side? And it's important to see that because it's kind of confusing. It's the upper, yes, because the lower is way over here at negative infinity. And don't forget, for negative infinity, we use negative 99. So for the left, we type into our calculator negative 99. For the right side, the upper, we type in negative 2.33. Do you see? We're just trying to calculate the shaded part. And this is always going to be negative infinity, which we type in negative 99. And the right side is negative 2.33. So that's what I'm going to put in my calculator. So let's put that in our calculator, negative 2.33. Second vars, number 2. Oop, that's not. Second vars, number 2. And we said negative 99, negative infinity for the left side, the lower, and negative, what did I say? Negative 2.3? 2.33. So that was what we typed in. Negative 99 was negative infinity, and then negative 2.33. Everything else stays the same. You hit enter, And that tells you what the answer is. You go always give your answer percentages in 4 decimal places. So the portion, that's why I said it was going to be very small. We knew that. You can see the shaded part that's very small. So the shaded part is 0.00990. 4 decimal places is just 0.0099, not even 1%. 1% would be a 1 right there. So 0.0099 is the amount that's shaded in. But that's not what they asked. So that's about 1%. If 500 PCs are selected, how many will use less than 106? So we already know this is the percentage. The answer we got is the percent that uses less than 106. There's the 106. So what we have to do is take 500 PCs and multiply that by the percentage times 0.0099. 500 times 0.0099, and we get 4.95. When you round that up to the nearest whole number, because they're saying how many PCs will use less than 106, PCs is whole numbers. So the answer to this problem is 5. 5 PCs, 5 out of the 500. 1% of them will use less than 106 watts. So, I mean, normally they would just ask you what percentage is shaded in. That's the answer. But since they said there's 500 PCs, how many? Well, it's that percentage times the number of PCs. And we get 5. So the actual answer to this particular problem is 5. All right, let's see what's next. If there is anything else next. Yes. Good. So we don't even have a picture or an what happened? Did I delete? What happened? I have no idea what just happened. Let me stop sharing for a second. I have to go back. I must have deleted the browser. Give me a second. Let me pause. All right, so this is the next problem. We just did that one. So here is the one that we're doing next. So there's no picture or nothing. So we know it's a normal curve. We might as well even, just talk about it and draw a normal curve on here really quick. You really want to draw your own picture. It says to qualify for a police academy, academy must score in the top 10%. Top 10% is like this this is the shaded in, the top 10%. This is the 50%. This is the mean. So I'm just calling this the top 10%. And we need to find that z-score for the top 10. The mean is 200. So once again, the mean is 200. That's where z is 0. Z is always 0 at the mean. Standard deviation is 20. Find the lowest possible score to qualify. So we need to find the z value. First, we need to find the z value. Oh, this is a good one. We need to find the z value and we need to find the score. So the score is like going to be more than 200. If the average to 200 in the top 10%, it's got to be more than 200. So this is going to take some knowledge from 6.1, and you guys haven't watched 6.1 yet. Maybe you've watched it, but you haven't done the homework. So if this is 10%, then the rest of this to the left of that z-score is 90%, right? It has to add up to 100%. So our z values to find to the left of a z-score is 90%. So I'm going to find this z-score for 90%. By the way, even though, do you see a z-score for 90% is the same thing as a z-score for the top 10. The z is going to be right here. But our calculator will only go to the left. So we have to find the z-score for 90%. If you didn't watch week 1 or 6.1, then you don't know how to do this. So I'm going to show that again. On the calculator, to find the z-score to the left of a certain percentage, you have to go to second vars, and it's second vars number 3. So I'm going to write this down here in a second, but we want to find a z-score if we have the percentage already. Do you see previously it says what portion is shaded in? Well, we know 90% is shaded in to the left. So we go to second vars number 3. It's called inverse norm. When I hit enter, it says, what area are you trying to find the z-score for? And I'm putting in 0.90, 90%. And it's going to tell me the z-score. Okay. So when I hit enter, 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 it gives me a z-score of 1.28. You always take the z-scores to 2 decimal places. So it gives me a z-score of 1.28. Coming back. So let me go through the whole process again. Here is a normal curve. The mean is 200. And we want the top 10%. We want to find this z-score. This is the top 10%. But we're going to go to second vars number 3, which is inverse norm. And this finds z-score for percentage to the left. That's why I said this is 90%. But to find the z-score, you can only do it to the left of that line to find of the z-score. You can't say 10% because 10% will give you this 10% down here. We want 90% to the left of the line. And when we calculated that, we put that in our score. We put in second vars number 3. Then we typed in 0.90 for the percent to the left. Percent to the left. And we got a z-score of 1.28. So that's what our z-score is, 1.28. Okay, so we're not done. It says find the lowest possible score. Now that we have the z-score, we need to know the actual score. We know this score was 200. And if it's to the right of the mean, we know it's going to be more than 200 now. The score on this police test has to be more than 200. The z-score is 1.28. Using the same formula, z equals x minus the average over standard deviation. We know our z-score is 1.28. We're trying to find the value. What is the score on the test? The average we know was 200. This is what we're trying to find. And the standard deviation, they told us up here, was 20. Do you see? So you have to use that formula, except we know the z-score now. We calculated using inverse norm. We have to find the value. We have to find x. So to get x at this point, you have to solve for x. I need to take the 20 over to the other side first by multiplying both sides by 20. Multiply by 20. So those cancel, and I'm going to do 20 times 1.28. 20 times 1.28, and I get 25.6. When I multiply those two together, I get 25.26. These canceled since I multiplied this by 20 and it was divided by 20. Now I need to take the 200 to the other side because I have to find out what x is. It's a minus 200 to take it to the other side. Solving, you have to add 200 to both sides. And sure enough, on the right side, x. On the left side, 200 plus 25.6 is 225.6. Assume the test score is normally distributed. Find the lowest possible score to be in the top 10%. We know it's going to be more than 200, and the answer was 225.6. So if you're not familiar with what I just did, a second vars inverse 3, that finds a z-score if you have the percentage, and that's in the 6.1 video. So there's a lot. I'm telling you, if you slack off on this section, there's a lot of, there's what, 25 questions on the test, and I'm gonna say 7 or 8 have to do with these z-score, this chapter 6, maybe more. Some of it's just basic, very, finding the percentages like in 6.1, but there's a couple that you have to do like this. Let's try this problem. You see, there's no normal curve drawn, so you have to fill it in yourself and draw it yourself. As soon as I know I'm doing a normal curve, I'm going to draw a normal curve. Okay, for a medical researcher wishes to select people in the middle 60%. If this is the mean, the middle 60% would be right here. Do you see? That's 30%, and that's 30%. So we want to find the z-score with the middle 60%. We want to find the z-score. It says we want to find both of these z-scores, the middle 30%, 30% on the mean on this side, 30% on this side. That's 60%. 30% on both sides of the average. If the mean systolic blood pressure is 120, if the mean is 120. And standard deviation is 8. So they give this to us. We have to find the x values in each of these. Before we can find the x values, we have to find the z values. So my question, to do the inverse norm, to do the second vars inverse norm, you have to know the percentage to the left. So to find this z value, can somebody tell me what percent is shaded into the left in red?
Would it be 20%?
Yes, it would be 20%, because this is 50%. And if we take 30% away from that, there's 20% left. So yes, 20% shaded in, and that'll tell us our z value for 20%. So we're going to go to second vars number 3, inverse norm, and type in 20%. But when you type in percentage, you got to type in as a decimal 0.20. So let's do that on our calculator to find that z value. I hate leaving this because then it all erases. So we're going to go to second vars number 3, and we're going to type in 20%. 0.20. When I hit enter, 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 I could focus it a little bit. Enter, 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 and enter. And it tells me the Z value, negative 0.84. Z values go to 2 decimal places. Negative 0.84.
So negative 0.84 is the X?
No, that's the Z. We haven't found X yet, unfortunately.
Okay.
So that was that one, this is what we're looking for, 60%. We're looking for the Z value here, the Z value here. We're actually going to look for the X values for each. We found this side to be this Z value is negative 0.84. Now that was 20%. And this was 30%. This was 30%. We have to find, that's an 8. So we had to find this Z value using second vars number 3. Can somebody tell me what percentage, second vars number 3, what percentage do I use to find this Z value?
Would it be positive 8.84? No.
No. Oh, that is the answer. But yes, yes, because it's symmetrical the way it is. Yes, but what percentage would I use to find the Z value?
20.
Well, what percentage is to the left of that Z value?
Oh, isn't it 80?
80, 30, 30, and 20. Do you see 60 in the middle and 20 more? So we would use 80% or 0.80. And yes, the answer is, if you put that in your calculator, second vars number 3 and type in 0.80. If you look, you get 0.84. You get a positive because it's symmetrical. You get a positive 0.84. So the right side is 0.84. The left side is negative 0.84. So we found both Z values. Now we have to find the X values for them. So here's the first one, and here's the second one. Don't forget the formula. X, or the Z value, equals X minus the average over the standard deviation. The Z value on this one was negative 0.84. We're trying to find the X value. The average, we already said, was 120. And the standard deviation was 8. And same way on this side, the Z value was a positive 0.84. So we have to find the X values for both of these, just like we did. We have to solve for X. First, you always get the 8 to the other side. It's divide by 8, so I'm going to multiply both sides by 8. 8 times a negative 0.84, and I get a negative 6.72 equals X minus 120. Then I take the 120 to the other side by adding 120 to both sides. Add 120, add 120. And X equals 120 minus 6.72. And I get 113.28. And on the right side, I'm going to do the same thing. Multiply both sides by 8. Multiply both, because that gets rid of that. If I multiply both sides by 8, I end up with a positive 6.72. Then I'm going to take that 120 to the other side by adding 120 again. Adding 120. I'm left with X on the right side. And 126.72 when I add them together. So the answer to this problem is, what is the range for systolic blood pressure anywhere from 113 to 126, if you take it to 2 decimal places. So this is the answer. It didn't say round to any whole number or anything, so I'm just going to leave it at 2 decimal places. So 113.28 to 126.72. That's the values, the averages. So it says find the upper and lower readings that would qualify of a person in the study. So anyway, if you have a blood pressure anywhere from 113 to 120 systolic, then you can come into this study. If you have really high blood pressure, then you can't. Anything over 126 or low blood pressure, you can't. All righty. And I think that's it. Let's see what else we have here. I'm not too worried. We're not doing any of this part. We're not going to be doing any of this part. We're not going to check the 5-number summary. And that's it. 6.3 is next, and I have the video for that already. All right, that's all I had for today. Once again, if you really weren't sure about what was going on, go back to 6.1 with your calculator and follow along. Do that 6.1 homework. Do the 6.2 homework this week. 6.3 is next week. I would even work on that now. The video is there already. Work on that 6.3 homework because on Wednesday of next week is review for the test, and I have that video already. So you should be caught up and finished with 6.3 homework by next week on Monday. But I say by this weekend, try to finish up to 6.3 homework. So next week, you're just reviewing for the tests. And you can do that test review that I have. I have a video of a test review. You could follow along and make sure you can do those problems. I'm going to hang around if you guys have any questions. You guys have a good weekend. I hope everybody went out to vote. I know we don't know the election results yet, but hang in there. Once again, I'm going to hang around. You guys have a good day. I'll answer any questions. Bye. All. Bellamy, did you have a question?